The origin of mountains is a result of a continuous process of sedimentation, erosion, and upliftment of the materials within the Earth's crust. If one takes the long history of the tectonic plate actions and the increased impact of these moving plates at the regional as well as the local scale, then we would go back 1,000,000 years and understand that the movements are mainly due to the tectonic seismic activity and are a part of the mountain building procedures or genesis. Lands around the planet are now being lifted to a vertical height that is related to the way gravity goes down. Some of this uplift is very slow and is always in a state of rising. Faster movements are found in the active tectonic regions. Zones with block faults are the most affected, and there are major belts of urgency that are found rising at a rate of around 20 meters per millennium and at around 6.5 feet every century. This is a great pace as per geological standards. The total uplift would be no more than 65,000 feet and would be more than twice the height of the Mount Everest. This would result in the entire orogenesis being completely wiped out. This chapter would deal with how the mountains have originated and how they have affected the geological process. Orogenesis and the process. Orogenesis occurs due to two kinds of process. It is intriguing that these are the main products of plate tectonics. It has been noticed that subduction zone rises to a high level in places where molten mantle materials and magma rise up. The crustal rock is raised through the addition of igneous or magmatic rocks. This is the creation of intrusive rocks of the plutonic kind and extrusive rocks like the volcanic rock. When plates slide along each other, they are exposed to a lot of forces of the tectonic kind, and this raises some blocks of the rocks which are relative to one another. Thus, all the downdrop, uplift, faulting, folding, and collision are all a part of these raised levels. The processes always are found to overlap each other. So any single mountain is always the effect of many kinds of orogenesis and the uplift periods. Take for example the Sierra Nevada in California. It has been created by the constant batholithic intrusions of the subduction along the western boundary of North America. This has occurred some 150 million years ago. The elevation and the form today in Sierra Nevada is more due to the faulting that occurred 35 million years ago and due to the continuing uplift that is caused by the isostatic rebound of the post-Pleistocene era. So, if one goes to see the bedrock geology of Sierra Nevada, we could say that a plutonic orogeny is responsible for all changes. Volcanic activity and the magmatic addition. Igneous rocks is a result of the solidified, cooled, and crystallized magma. When this is seen to occur underground, what we get is plutonic rock of the intrusive kind. This forms large bodies called batholiths, and there are smaller extensions which are found squeezing between the joints. These joints are made up of rocks that have existed earlier. The intrusive forms that came up later have a great surface to volume ratios. They are found to have a fine grained texture. These resemble an extrusive igneous rock and are not usually intrusive. Whatever the structure is, the magmatic intrusion is shown to represent the constant addition of material to the crust. The crust rises and gradually they are pushed up from below, leading to the formation of mountains. The more severe forms of magmatic addition are seen to occur when the molten material reaches the surface as a volcanic extrusion. There are at least 1,300 volcanoes of many sizes and shapes across the world. These are active and can erupt at any time. There is a volcanic eruption of some type or the other, and this is not destructive to human life and property. This is occurring once in a week somewhere in the planet. Volcanoes and how they work. Volcanoes are found in various sizes and shapes with one feature in common. They are openings that link the surface of the earth with the magma inside. This is a plumbing link for the rock cycles which are in the igneous phase. Thus, volcanoes are a network of pipes that allow materials to come to the surface. They are found above the earth's surface like a vent. At times, an explosion of a volcano can spread to a great size, thus creating calderas. A number of such eruptions result in the formation of mountains. Kinds of volcanic materials. Volcanoes can be lava tephra and pyroclastic flows. Lava is a simple magma that is found flowing freely on the surface of the earth. The basaltic lavas have very low viscosity and usually flow freely and smoothly like a river. They travel at a great speed of up to 30 miles per hour and stretch for many miles. They then solidify into a flow hat resembling the top part of the brownies. Tephra consists of more materials that usually the volcanoes expel in the air, and they are the second class of emissions of volcanoes. Tephra deposits are fine-grained ashes and are at times shaped like pebbles too. They are a risk to life and are a greater threat to property in general. Mount St. Helens eruption is one such example of tephra deposits, as it sent ash to around 19 kilometers in the atmosphere. Most of the northwestern part of North America got engulfed in this. Pyroclastic flows are snow-covered volcano slopes that release a torrent of mud, water, trees, and rock cascading down. This deadly flow goes at a speed of around 200 miles per hour and is called lahars. In the year 1985, for example, Nevada del Ruiz, a town of Armero, was destroyed by a lahar. Mountains and volcanic origins. Mountains and the various ranges have a varied kind of origin. Some mountains are the remains of erosions in plateaus. Others are results of cones that are built by volcanoes. Mountains can also be formed by domes pushed up by the igneous rocks. For example, the Black Hills of South Dakota have been formed like this. When huge blocks of the surface of the earth are pushed up, then it forms a range of mountains. Example, the Basin and Range of Nevada in Arizona, in New Mexico. Fold mountains. Most of the mountain chains of the planet are fold mountains. They can also be very complex structures who have found their origin due to the igneous activity in the past. The growth of these ranges is usually preceded by an accumulation of a lot of sediment. This is seen in the sedimentary rocks of the Appalachian Mountains, which reformed in a huge geosyncline that stretches from the states of Gulf in the northeast through the parts in New England. This is in fact today the greatest thickens of sediment deposits that's found here, geosynclines and their formations. Let us see how the geosynclines affect the sediment deposits and how they make up the continental shelves and rise. Most of the geologists today feel that the sediments of the geosynclinal nature are found in the mountain ranges that were deposited here in the initial stages. The period in between the sedimentation and the thrust faulting resulted in the upliftment of mountains, which resulted in the formation of mountains. The movements on the surface of the earth caused the building up of sediments, which led to the formation of mountains with uplift. Sharp peaks formed and they were attacked and leveled. In fact, mountains are the most rejuvenated forms of continuous uplifts. The best modern analogues of geosynclines appear to be the thick deposits of sediment making up the continental shelves and the continental rises. Most geologists now believe that the geosynclinal sediments found in the mountain ranges were initially deposited under similar conditions. The period of sedimentation is followed by folding and thrust faulting, with most high mountain ranges uplifted vertically subsequent to folding. The movements of the Earth's surface that result in the building of mountains are compression, which produces folding, thrust faulting, and possibly some normal faulting, tension, which produces most normal faulting, and vertical uplift. Mountains are subject to continuous erosion during and after their uplift. Sharp peaks are formed and are subsequently attacked and leveled. Mountains may be entirely base leveled or they may be rejuvenated by new uplifts. The plate tectonic theory. According to the plate tectonic theory, the lithosphere has many plates and every plate is made up of the oceanic crust. There is also a continental crust, thus the lithosphere is made up of both combinations. These are always in a state of motion and are colliding, swiping or grazing against each other. They change in size and shape, and where two plates collide, the compression stresses are usually found along the margin and border of the plate which contain a continent. These stresses result in the uplift of the entire continental shelf and the deformation of the structures, which results in the formation of faulted chains of mountains. Thus, it has been seen that mountains are all a result of the upliftment of materials of the earth and the deformations caused due to the continuous movements of the earth. How are mountains formed? Mountains, thus, are the most apparent landforms in the world. Any isolated mass of rocky material is a mountain, and there is no shape or height required to define a mountain. Mountains are thus formed with the help of erosion, volcanic and structural processes. The formations could be due to the folding or faulting of materials on the surface of the earth. The topography of a mountain shows the relation between the forces of erosion and the upliftment of forces within. Mountains of the volcanic kind. Mountains that are formed due to volcanoes are called volcanic mountains. Example, southern Idaho has such a mountain in the Snake River Plain province. These volcanic mountains have an individual cone of cinder along with an extrusive rock of the igneous kind. The volcanic material is believed to be extruded through a central opening in the Earth's surface. They pile up to form a cone. In fact, it is said that in Idaho, the volcanic mountains are usually smaller than the other mountains. They are less than 1,000 feet high. They are usually isolated and are not distributed. They are, however, aligned commonly along the fissures or the rifts like the Great Rift of the Snake River. These mountains are normally shaped like a dome and are symmetrical in the view plan. As a rule, these mountains are very susceptible to erosion. Erosion mountains. Erosion mountains are those that are found in the uplifts of the Earth's crust. They are the main features in places like Idaho. The erosion mountains here have been mainly carved due to the presence of running water and glaciers and have formed due to years and years of erosion in the valleys here. Structural mountains. Structural mountains have been created by the regular structural activity like faulting and folding. These are formed when huge blocks of the Earth's crust move up the valleys along usual and normal faults. Volcanoes are mainly found near hot spots and boundaries. They usually differ in type as per their setting. Usually, mid-ocean spreading centers and hot spots produce less lava of the basaltic kind. However, subduction zones produce more andesitic lava, which is felsic in nature. There are silica compounds in the lava which flow like cold molasses. The subduction zones also carry a lot of water vapor under high pressure. Thus, they are generally a bank of stored energy which are released suddenly in a major eruption. Basaltic shield of hot shots and the mild ocean rift zones are not very violent volcanic zone types. They produce eruptions of the lava which create concave down domes or layered flows of basaltic lava. This activity at times is sustained for a long time, and then when it comes out of a single hole, it causes the formation of mountains. A typical example of such flooding of basaltic rock is seen in the Deccan Plateau and the Snake River Basin in Colombia. Geology of mountains. Mountains usually are a series of rocky formations of distinct geological origins. This mountain system usually stretches over a large area. The rocks that make up the mountains are formed years before the mountain is made. The core portions of the mountains are made up of the continental crust that has formed billions of years ago. Gradually, the mountains take shape due to the extensive tectonic activity that causes the rugged landscape to form. For example, the Laramide orogeny is an example of a formation that formed around 80 million years ago and after the continuous erosion by glaciers has resulted in the present-day formations. Tectonic forces and rock formations. The rocks in the Rocky Mountains were formed much before the formation of the mountains. The tectonic forces are responsible for the formation. Take, for example, the Precambrian metamorphic rock, which is the core of the rock formation in the continent of North America. These date back to more than 1.7 billion years ago. Sometimes during the Paleozoic period, these were lying deposited below a sea. These ancestral rocks were the base for forming the future mountain building processes. These resulted in an upliftment of the mountains, and this Precambrian metamorphic rock forced the layers of the limestone and rock below the sea upward and resulted in the formation of mountains. Terranes and collisions. Terranes are a variety of tectonic environments. They collided with the western boundaries of continents some 350 million years ago. This resulted in the continental crusts being carried along by ocean plates of the subducting kind. They were all swept into the zone of subduction and they barely escaped the edge of North America. The terrains are ancient island arcs very similar to what we see in Indonesia and Japan. They are also seen as parts of the crust of the oceans merge with the continental borders, and there are some others which belong to the isolated mid-oceanic landforms. Usually, these oceanic plates are found below the continental plate and collide at a boundary. The oceanic plate sink at a higher angle and there is a volcanic arc that grows here above the plate. Magma and formation of mountains. Magma is usually generated over the slabs of subducting zones and giant arc-shaped mountains are formed with the ash and lava that is spewed out of the volcanoes. Below this lie great masses of molten rock that are hardened and injected in the right places. For many years, the results of the collision of plates were concentrated only on the borders of the continents. Gradually, they started spreading into the mainland. Raising of the mountains. The present-day mountains are raised millions of years back due to the continuous process of mountain building. This is very similar to a rug being pushed on a hard floor. The rug wrinkles and bunches up to form mountains. For example, in Canada, the subduction of the terrains and the Kula plate resulted in pushing them into the continent, thus pushing up the ancestral rocks up like a rug. In this case, the Canadian shield is a hard floor. Geologists still are gathering evidence to find out the exact cause of the continuous rise of the mountains, and they have found that it is usually due to the subduction of the Farallon plate. Normally, a subduction zone has the oceanic plate sinking at an angle and a volcanic arc growing above it. During the growth of the mountains, this angle might get flattened and thus the mountain starts growing in inland zones. This angle of the subducting plate increases the related friction of the masses above it. Many thrusts of pile sheets on top build the huge mountains that we see. Sedimentary deposits and formation of mountains. Sedimentary remnants angled along the flanks of the range of mountains that we see are a result of the rocky formations like Cretaceous sandstone formation that run beneath the Earth's crust today. When the mountains were in the state of formation, they were all in a condition of high plateau stretching over a vast area. In the last 60 million years, all these high-level lands got eroded and have begun to reveal the ancestral rocks below, thus forming the landscape of the mountains today. Case studies of mountain formations. There have been many periods of glaciations that have occurred from the Pleistocene epoch, which is some 70,000 years back. It comes here till the Holocene epoch, which is around 11,000 years back. The ice ages have left their identity in mountains across the world. There are many glacial landforms and cirques and valleys which have caused the history of the mountains to undergo a transformation. The glacial episodes at Bull Lake, the fact that 90% of the Yellowstone National Park was covered by ice, and such examples show that the mountain formations are related to the ice age that existed in the past. Conclusion. All of the geological processes above have left a complex set of rocks exposed at the surface. For example, in the Rockies of Colorado, there is extensive granite and genesis dating back to the ancestral Rockies. Such cases lead us to believe that mountains have originated from the lava and the volcanic eruptions in the past and are a continuous process of forming ideal landforms through years of erosion. Any kind of composition below the earth is made up of lava, magma, and other substances which constitute the basic structure of a mountain. With so much in tow and years of soil formation and rock degradation in progress, the volcanic eruptions and the natural calamities have contributed to making the mountains the way they are today. Add to this the tectonic nature of the Earth's crust, and there is a perennial process of moving rocks and formation of small landforms across the planet. Origin of mountains is thus a link to the past and the possibility of more such connections in the future. What we see of the mountains today is just the tip of the iceberg, as it could change shape or become even bigger tomorrow.